Hello, everyone. Good morning, good evening. My name is Sandeep Lohia. I am a cloud and automation delivery manager in customer experience, aka CX, based out of Dallas metro area. And I also have with me today Vishesh Kansal, who is a solution architect and who is taking care of multiple service providers account for automation. So today, we would like to present a true story of a tier one service provider in the USA. So no matter which service provider we talk to, or even the large enterprise customers, they all want to achieve more tasks or get more work done in a given maintenance window, as we know that they have limited number of maintenance window in a year. So with the mobility and data usage growth and 5G expansion, the service providers are under tremendous pressure about scalability and performance challenges. So now I have been working on NSO ever since Cisco acquired TLF in 2014, and I have seen these challenges firsthand personally. So when we deal with a service provider network, the scalability is huge. Uh, some of the customers have hundreds of NSO nodes working in HA or LSA mode, uh, taking care of hundreds of thousands of devices. Uh, and so this throws operational challenges to maintain, configure, and upgrade these devices. And that adds more pressure to the maintenance window to get more work done. So we'll be presenting a case study where we'll tell you how we use NSO 6.0 features to resolve these some of the problems. So here's the agenda. So since it's a 30-minute session, so we'll quickly go over the agenda. The key objective of this session is to educate everyone about upgrading to NSO 6.x because the features, it's the rich set of features it brings. And we understand most of the customers are sometimes reluctant to upgrade any automation tool due to obvious reasons. Sometimes you need lots of code refactoring and also endless testing cycles. But with NSO 6.x, since it is you require low code, no code kind of changes in the service packages, so the upgrade is relatively easier. So we'll briefly go over the complexities of the use cases and the challenges the customer was facing. Then Vishesh will deep dive into the new set of features offered by NSO 6.x and also how some of those features were utilized to take care of the problems customer was facing. And then finally, we'll share the comparative test results between 5.x and 6.x. So let's get started.
Hello everyone, my name is Vishesh Kansal. I'm solution architect in CX automation delivery team. I'm also based out of Dallas. So I will start with the complexity that we were facing in our customer environment. Let's start with that. In our professional lifespan, we have seen the technology evolving. The pace of change in the technology is very fast. We have seen technology evolving from 2G to 3G, 3G to 4G, and now 5G. 5G itself comes with a lot of complexity and the operational challenges due to its complicated architecture, different kind of devices involved, like virtual network function, cloud native functions, and the complex configuration, etc. The another big challenge that we had the large configuration set. Generally, tier 1 service providers has huge configuration and the complex configuration. Our customer also has a very huge configuration set. Think about it, StarOS devices having more than 40K to 80K lines of ECS configuration. And moreover, the StarOS device is a CLI device and its Yang model is also complicated. The third challenge was large install base. Our customer has huge 5G network that need to be managed. If you have a large install base, so then the network operations becomes tedious. Think about that you have to manage more than 15,000 StarOS devices and more than 3,000 cloud native devices with a huge configuration. It's a challenge, right? Because 5G is a new technology, so then it's all the use cases to manage 5G network are complex. At the same time, the frequency of day-to-day operations on 5G network, like day to configuration changes, software upgrade, etc., the frequency is very high. Now, let's talk about what are the exact business requirement that we had from our customer. There are different scenarios where service provider need to apply the network operations entire on the entire network. For example, if they have to if they have to uh, do a security patch or break fix or launch a new service. Similarly, out of band changes are very common in network. So if you have the out of band changes in your network device configuration, then the configuration audit becomes necessary to run periodically so that you can get the delta against the golden configuration and then apply to the devices all over the network to make them compliant. The third scenario is software upgrade. Service provider has to upgrade multiple sites time to time in a given maintenance window. The software upgrade takes very longer time if you have large number of devices. So all these complex operations need to be done in a single maintenance window. And because it takes longer time, so generally it leads to the network the maintenance window timeout. The customer expectation here was there should not be any maintenance window timeout. The another business requirement was the current solution is integrated with customer's northbound system. This northbound system triggers request to NSO for performing the network operations. The operator goes to the northbound system, it creates the change request. Number of devices in each change request may vary. So if the operator has to apply the configuration changes all over the network, so thousands of requests, thousands of REST conf calls are sent to NSO. NSO has to authenticate those calls, those REST conf calls, and then process them in the given maintenance window. Not to mention, high availability is a must for this kind of complicated environment, production environment. Now, let's have a look What were the bottlenecks or challenges which we were facing in the current solution? First one is limitations in processing the parallel transactions. So whenever the right transaction starts, it locks the CDB, and it locks the CDB until it completes. By that time, other transaction has to wait for release the CDB lock, and they have to wait in the queue. Another thing, the check seek and sync from takes longer time. And if you have a large number of devices and the huge configuration, so then it becomes more tedious. So in the current solution, the check sync and sync from operations were taking very long time. All the use cases in our solution are using these expensive check sync and sync from operations. Another bottleneck that we were facing was NSO VM resource utilization. While processing these complicated operations, the NSO VM resource consumption was very high, like CPU memory utilization. At the same time, the resting memory consumption was also high because the customer has the large configuration. Next bottleneck that we were facing was parallel REST-conf authentication. As I mentioned, the northbound system is sending thousands of REST-conf call to NSO, and NSO has to authenticate those REST-conf calls. So these calls are authenticated with the auth cache. But when this burst of REST-conf calls comes to NSO, several requests were being authenticated, but few were not being authenticated. So it was slowing down the overall process time. The current solution also use the operational DB for storing the API request and response metadata. Multiple threads try to read and write on the operational DB in parallel. We observed some limitations while reading and writing operational DB in parallel in NSO 5.x. Another challenge is NAD migration. Because 5G is a very new technology, so then we are getting very frequent build release for 5G devices. Whenever we get a new build, then we have to migrate the NAD. It becomes more tedious and time consuming if you have multiple NADs to migrate. All right, now let's have a look that what are the NSO 6.x features which helped us to solve these problems. First is parallelized transaction handling. In NSO 5.x, as we know, the transaction lock the CDB and then other transaction has to wait for releasing that lock. In NSO 6.x, parallelized transaction handling has been improvised a lot, which overall increase the throughput and the speed of service provisioning. Next feature is lockless dry runs. The current solution is extensively using the dry run, like configuration audit, configuration changes, use cases are generating the dry runs for thousands of devices. In 5.x, the dry run was locking the CDB, so that's why it was slowing down the overall processing time. But in NSO 6.x, there is no lock by the dry runs, which in result improving the overall performance. The next is sync from. If you do the individual sync from on thousands of devices with large config set in NSO 5.x, it is taking longer time. But in NSO 6.x, it has a very significant improvement. In NSO 6.x, the operational DB also has been improved to read and write in parallel. That again helps us to reduce the overall processing time. Next is live status improvement. Our current solution is using the pre and post checks before and after any software upgrade or configuration changes. And these pre and post checks are using the live status feature to run on the devices to pull the operational data. NSO 6.x has improvement in the live status command, which is making faster to pull the operational data from the devices. Another improvement is auth cache. NSO 6.x has optimized auth cache, which makes the burst of request to utilize it for authentication. And in result, overall it is saving time to process the request. The NAD migration also is quicker and faster in NSO 6.x. That is helping a lot. Next is HA raft feature. I have not used HA raft feature yet, but I'm excited to use it in the near future because it looks very promising to me. It provides very cool features like quorum rights, automatic recovery, and optimized catch up in case of NAT split. I believe this feature will help a lot in the critical production environment. Last but not least is NSO Insight. So in NSO 5.6, we don't see any straightforward way to analyze the NSO performance. But NSO 6.x has a way to visualize service provisioning and the transaction per time unit. I believe this can help in different ways. Number one, dimensioning of NSO server for given customer and use cases, and debugging a operation which is taking longer time. All right, now it's time to have a look on the numbers. Now let me show you how NSO 6.x helped us to meet the customer expectation for performance and the scale. Let's start with the sync from operation. This is our test bed where we have executed the test cases with different scenarios and scale. This test bed has one NSO pair, HA enabled, and it has 16 vCPU, 128 GB memory, and 512 GB hard disk. All the test cases has been executed in the batch of devices like 50 device, 300 device, 600 and 1200 to monitor the overall performance improvement. We have used the StarOS devices in all the test cases. Here we have captured the CPU and memory utilization by NCS and the Java process. In addition to that, we have monitored the overall processing time to complete these operations. So if you see the result, NSO 6.x, you can see the drastic improvement in the sync from process. It is almost taking 1/4 of total time taken in NSO 5.x. Great improvement, right? Let's move to the next use case. We have used the same test bed for testing these other use cases. In this configuration change use case, the only difference is we have set the thread pool 16. This thread pool 16 is basically equivalent to the number of vCPU available on the NSO server. What it means is only 16 threads will be executed at one certain point of time, and each thread will be processing single device. In this test case, we are pushing 4000 line of ECS configuration to StarOS devices to test the scale. Here also you can see clearly it is it has reduced almost half of the total processing time in NSO 6.x by utilizing NSO 6.x features. Let's move to next. Configuration. Similarly, we have seen the great improvement in the configuration audit use case. Here also the test bed is same. The only thing we have taken the devices which are having large configuration, almost 70K to 80K lines of config, and they are having the delta up to 1000 lines of config. In the config audit use case as well, we have observed 40 to 50% improvement in the overall performance. Last but not the least, the pre-post check. As I mentioned, the pre-post checks are extensively using the live status command that has been improved in NSO 6.x. So if you see here also we are getting a great improvement in the overall performance. So these test results may vary based on the given environment and the use cases, but in summary, we are getting almost 40 to 80% performance improvement, and the resource utilization is also very optimal. So now I will hand over to Sandeep for the conclusive remark.
Thank you, Vishesh. Very impressive comparative data between 5.x and 6.x. And I'm sure it will encourage many customers to upgrade to NSO 6.x. So the only request I have today is like don't be shy to upgrade to NSO 6.x. It can be a good friend with very minimum code changes to your service packages. You can take advantage of the features provided by NSO 6.x. It has great performance and scalability improvements. And also, Cisco NSO engineering and CX are here to help. So, and if you have any questions, please drop an email to this mailer, cx.americas-automation-delivery at cisco.com. Thank you for your time.